Hi guys, and welcome to this, the antiderivative of e to the power of kx. This is an extremely short video, he says, hoping, but the rules are the same. If you know me, then those are the questions I'd like to do from the Cambridge Essentials textbook, which is actually a really good series, by the way. By the end of this lesson, we should be able to understand how to find the integral of functions in the form e to the kx. But let's just do a little bit of a recap. We knew from previous lessons that if you had y equals e to the x, then we found out that y dashed just so happened to be y equals e to the x, which I thought was just awesome, brilliant, fabulously wonderful. So that would suggest if the differential of e to the x is e to the x, then the integral of e to the x is also e to the x. Well, we can use that now to help us find e to the kx. How? Well, once again, by substitution. I love this method. Yes, you can learn formulas, but the point of it is, why use lots of different methods? You'll get faster at doing it, and there are shortcuts, but let's do an example. So we got the integral of e to the 3x dx. Well, I would like that just to be e to the x, or e to the u, or e to the b. It doesn't really matter, but I'm going to use and say, well, 3x is complicated, so let's make u equals 3x. So I know that du by dx is going to be 3, because I'm now going to write that as e to the power of u. I can't write dx there because the examiners will throw a mental, because I can't now integrate e to the u with respect to x because there's no x's in it. So I need to replace this dx. And if you remember, I can now say then that du upon 3 is equal to dx. So I can take that dx out and put du upon 3. We can move any of those multipliers outside the brackets, e to the u du, and we know that the integral of e to the u happens to be e to the u. Fabulous, fabulous, fabulous. So that becomes 1/3 times e to the u plus c. Is that my final answer? No, because we wanted it in terms of x, and so ultimately my answer would become 1/3 e to the 3x plus c. Fabulously wonderful. What about this example? Now again, notice the use of the brackets. The brackets have to go around each of those individual terms. Miss the brackets, lose the marks. So in this situation, I'm going to split it up as the integral of e to the 4x dx minus the integral of 3x dx. Writing it out longhand because it makes life a lot easier for me to understand what I'm doing. This, I know, is just going to become 3x squared upon 2. I'm going to have to add a constant. Now, you're going to probably turn around and say, well, does that mean I have to add two constants? Theoretically, sort of, maybe, yes-ish. But bearing in mind a constant plus a constant just becomes a totally different constant. We don't actually need to write two c's. We just write the one. We just pretend it's both of those constants together. Who knows? But I want this integral of e to the 4x. So I'm going to break out and say integral of e to the 4x dx. Let u equals 4x. So du by dx becomes equal to 4. So du on 4 becomes equal to dx, which means I can now write that as e to the u multiplied by du on 4. The fraction moves outside, e to the u du, and we like the integral of e to the u because it just happens to be e to the u, so that becomes 1/4 e to the u plus c, but I don't want it in terms of u, I want it e to the 4x plus c. And there is my final answer. No, it isn't, because remember we broke it out, so we need to put back the 1/4 e to the 4x. I don't need the additional plus c because that c and this c make a whole new c, and so we'll just leave it as plus c. And there, ladies and gentlemen, is my integral. What about negative values? Is this where it all goes horribly wrong and I need moduluses? No, not really. Let's see. We don't like minus x, so let's make u equals minus x. Du by dx then becomes minus 1. So du becomes equal to minus dx, or dx becomes equal to minus du, which is probably the one that we actually want. So this becomes the integral of e to the u, and that becomes minus du. The minus sign moves outside, e to the u du. So that becomes minus e to the u plus c, or minus e to the minus x plus c. Wow! Now, again, if you love a good formula, ladies and gentlemen, go on, you have to admit it. But there you go. There's one of the 27 I'm sure you're going to have to remember. And this is the one here that says, basically, if you want to go the integral of e to the kx dx, you just do 1 over k multiplied by e to the kx plus c. So, for example, if I had the integral of 3 e to the 2x dx, that becomes equal to 1/2 times 3 e to the 2x plus c, or 3 onto e to the 2x plus c. Yes, in that situation, maybe using a formula was a little bit easier, but I don't want to keep remembering 27 different formulas. All right, 5 minutes and 46 seconds. I've got to have missed something. There's got to be something else here. Nope, ladies and gentlemen, that was the antiderivative of e to the kx, done in 5 minutes and 55 seconds. See you again. Take care. Hey guys, if you've enjoyed watching this video, why not tune in and subscribe to get updates of when I do other videos. Alternatively, click this video that's coming up now, or just zip on over to MaffsGuru.com, MaffsGuru.com, where you can actually access all the videos in a nice, easy to use way.